So now we're going to find the determinant. Hopefully we remember how to find the determinant. We take this, multiply by this, subtracted from this times that. So we have 0 multiplied by 5, which gives us 0, minus 2 times 2. So we are left with a negative 4. So I'm going to rewrite it down here, negative 4. So we have 2 times 5 minus 3 times 2. 3 times 2. We're left with a positive 4. 2 times 2 minus 3 times 0. We're left with positive 4. I like to cross these out so that I know that I've done them so I don't get confused. 4 multiplied by 5 minus 2 times 0, we're left with a positive 20. 1 times 5 minus 3 times 0, we are left with a positive 5. 1 times 2 minus 4 times 3, we're left with a negative 10. 4 times 2 minus 0, we're left with a positive 8. 1 by 2 minus 2 times 0, we're left with a positive 2. And 1 times 0 minus 4 times 2, we're left with a negative 8. So here we have this new matrix, N. But we are not done there. So what I'm gonna do now is write on top of these numbers positive, negative, positive, negative, positive, negative, positive, negative, positive. Always in that order. So what I like to do is pretend that these are positive and negative ones, and I'm multiplying each of these numbers by that. So when we have that, we have positive 1 multiplied by negative 4. We know that leaves us with a negative 4. So we're left with negative 4. A negative 1 multiplied by 4, we're left with negative 4. Positive 1 multiplied by positive 4, we're left with positive 4. Negative 1 multiplied by 20, we're left with negative 20. Positive 1 multiplied by 5, we're left with positive 5. Negative 1 multiplied by negative 10, we're left with positive 10. Positive 1 times positive 8, positive 8. A negative 1 multiplied by positive 2, we're left with a negative 2. And positive 1 multiplied by negative 8, we're left with negative 8. So we just, n is equal to that. So what I'm going to do now is I'm going to take my blue highlighter and I'm going to draw a diagonal always in this direction. And this is going to be used as a reference point. Okay, so I have my blue diagonal, and like I said, this is a reference. So what I'm going to do now is switch the numbers that are across the diagonal. You're probably like, what? So where negative 20 and negative 4 are facing each other, we're going to switch them. So what we're going to be left with, we have to write a whole new matrix box again. Now n is equal to, we come here, see, well, first what we do, we're going to rewrite the numbers that are on the diagonal because they won't change. So we had down here, we had negative 5, negative 4, 5, and negative 8 on the diagonal. So we write negative 4, 5, negative 8. Oh, my handwriting is terrible. So we see that negative 20 and negative 4 are across from each other. So we're going to switch those terms. So we're going to put negative 4 where negative 20 was, and negative 20 where negative 4 was. We come back down here, and 8 and 4 are at opposite ends. So we're going to switch them. So we're going to put positive 4 here and positive 8 there. And then finally, we're going to switch the -2 and the 10. So we're going to come here and we're going to put 10 here and -2 there. Now we have our matrix, but we are not done yet because we still have to deal with the determinant. Okay, so we have our matrix here, our new matrix, and we're just going to multiply it by the determinant that we found earlier, which was -20, and then we're done. So to do this, we put 1 over the determinant, which is -20, and we're going to multiply it by this matrix. So what I did was convert this to decimal. So 1 divided by -20 is actually -0.05, and then we can just use that to multiply by this, and then we get the matrix, the answer, the full matrix. So -0.05 multiplied by 4 gives us a +0.2. Multiplied by that gives us a +1. Multiplied by a -0.05 multiplied by +8 gives us -0.4. Multiplied by -4 gives us +0.2. Multiplied by 5 gives us a -0.25. Multiplied by -2 gives us a +0.1. Multiplied by +4 gives us -0.2. Multiplied by 10 gives us a -0.5. And multiplied by a -8 gives us +0.4. And we just found the inverse of the matrix A. Thank you for watching.